This is Chapter 2, Lesson 2, Linear Relations and Functions. Um, Anytime you get a graph of a straight line, that is called linear. So if they're not linear, or if it's not a straight line, it's called nonlinear. When you're looking at equations, the way that you can determine if it's linear or nonlinear is by following these simple rules. Anything that when you see your variable, it can have constants, like that's just a number, that's either added or subtracted or multiplied by the variable. But you cannot multiply a variable by another variable, which is why this one here is under nonlinear equations. Also, the linear equation does not contain variables with exponents other than 1. So here, this one has a variable with a squared. Okay, the exponent is 2. We can't have that or it's nonlinear. This particular example, if you rewrote it with its exponent, it would be x to the 1/2 power. That's what creates the square root of x. So x to the 1/2 power, that's not a value of 1, so it cannot be linear. It's not called linear. And then here we also can't have our variables in the denominator. So as we look at examples that do represent linear equations, in this case, the variables are only to the first power, so that's okay. Again, the variable is only to the first power. Here, the variable is being multiplied by a constant. Negative 2/3 is just a number, so just, it's not being multiplied by another variable, it's just being multiplied by another number. So that's okay. And here, the same thing. If you wanted to call it a linear function, the ordered pairs, first of all, it must be a function, so each domain only is only paired with one range value, and it can be written in this form: f of x equals mx plus b. You may have heard of y equals mx plus b, the slope-intercept form. That is the same thing here. M and b must be real numbers. So we've talked about the real number sets: natural, whole, integer, rational, real. Okay, so all of natural, whole, integer, and rational, it must be one of those, or it can be irrational, because that's part of real numbers too. So let's take a look down here and determine if the function is linear or not. So in this case, we have an x, and it's only to the first power. We don't see the 1, but we understand it. And there's nothing, it's adding something, it's being divided by a constant. That's all okay. So in this case, yes, this is linear. Okay, let's take a look at number 2. Number 2, if we only had this top part, it would be okay. But because the variable is in the denominator, we say no. In this case, our variable has a power or an exponent of 2. And to be linear, it must only be 1. So again, no. And here, our variable is being multiplied by a constant, and it has subtraction by a constant also going on over here, which is okay. And it's also written in the form mx plus b, in this case plus a negative 21 or minus 21. So this is okay. We say yes. That's about linear functions and relations. I'm going to split this section into 3 parts. So if you will look at part 2 now, you'll learn about standard form.